is 2000 hertz. If the self-inductance in the circuit is 5 millihenry, what is the capacitance in the circuit? So this is a series RLC circuit. And the resonance frequency is the frequency when Z is minimum, and that happens when XL equal to XC. That's omega is equal to 1 over, let's see. So they give you this guy, well, they give you F, but they've given you this, and they've given you this, and they want you to find that. So C is 1 over L times omega squared. L is 5. So that's 10 to the 6, and so this becomes 10 to the minus 3. No, 10 to the 3. That goes on top, becomes 10 to the minus 3. So 10 to the minus 3 farads, 4 pi squared times 4 times 5. So 1.27 microfarads. Okay. This says, what is the resonant frequency of a resistor, capacitor, and inductor connected in series? Okay, and so you're connecting a resistor. And the resonant frequency is when XL is equal to XC. C is 5 microfarads. So that's 10 minus 3, and that comes to the top, so that's 10 cubed. Omega is the square root of 10. And radians per second. So if this combination is connected to a 100-volt source operating at the resonant frequency, what is the power output of the source? So the power output, average power, is V max, I max, cosine phi over 2. At resonant frequency, at resonance, what is phi equal to? when XL equal to XC,
Oh, 0.
0. So, and at resonance, phi equal to 0 and Z equal to R. So 100-volt source, 100. And Z is equal to R, which is 100 ohms. So 50 watts. Okay. What is Q of the circuit? Q of the circuit at that resonance frequency, you're delivering 50 watts of power, and at this frequency, you're delivering 50 watts of power. And if you get to this frequency, so this is delta omega, okay? And if you get to that frequency, the power delivered will be half as much. Okay, so at this frequency, the power delivered will be half as much. For that, so the quality factor is omega naught over delta omega, and it's omega naught L by R. Let me make sure of that. Yeah, L by R. Okay, so what you want is a sharp peak. What is the resonant frequency? We found the resonant frequency. There's the resonant frequency. L by R, okay. Okay, so that's 632 divided by 100, 6.32. So the quality factor is 6.32. That's just a dimensionless number. And let's actually, the problem doesn't ask us that. What is the bandwidth of the circuit? They do ask us. Bandwidth is this guy. And that's over R over L. Okay, so what this means is, so half of omega by 2 is 25 radians per second. So omega naught was 316 radians per second. So omega naught plus delta W by omega by 2 is 316 plus or minus 25 radians per second. So if you go to 316 plus that, 341 hertz, 341 radian, this is 316. That's when you get maximum power. And if you operate at 341 radians per second, you're only delivering half the power. And if you're operating at 316 minus 25, which is 391, 291, then you're delivering half the power. So that's what that means. So if this was a receiver and you were FCC, what you would say is you can broadcast at this frequency, and the next frequency you want to broadcast is that one. So that's how they decide. If you're FM radio, you have 89.9, 90.1. So those are 0.2 megahertz apart. That's how they decide that. Okay. And you would learn all of that as an electrical engineer. So a step-up transformer is designed so that the output of its secondary winding is 2000 volts RMS, when the primary winding is 110 volts line voltage. If there are 100 turns in the primary winding, how many turns are there in the secondary winding? All right, so if you look up so V2 is N2 over N1 times V1. Okay, so if you put RMS values, you get RMS values. This is 2000 volts, this is 110, and they give you 100 turns in the primary winding, so N2. V2 is 2000 volts. So N2 has that many turns. And so now they say for part B, if a resistor across the secondary winding draws an RMS current of 0.75 amps, what is the current in the primary winding? So what is the current that flows in here? Okay, again, we've said that no free lunches, so power input is equal to power output. Okay, so VRMS, IRMS, this is the input power, should equal VRMS, IRMS output. So IRMS input is V out, V in, I out. Okay. I didn't write RMS, but so I in is V out was, what was the voltage? 2000 volts. Input voltage was 110 volts. And output current was 0.75 amps. Okay, so current went down from 13.6 amps to 0.75 amps. And voltage went up from 110 volts to 2000 volts. So this step-up transformer steps up the voltage and steps down the current. A transformer is used to supply a 12-volt model train with power from a 100-volt plug. The train operates at 50 watts of power. What is the RMS current in the secondary coil? So this is the source, this is plugged in, and this is the train. Okay. So the output power is 50 watts, which is VRMS IRMS. So this is 12 volts. So 50 watts over 12 volts. So the current in the train is 4.17 amp.
Aren't you missing a square root of 2 in there?
These are RMS values,
Okay.
and that's average power.
Okay. You got 5.89 on the PDF, that's why I was asking. 'Cause you did for IRMS, you did multiply it by square root of 2 times 50 over 12.
Yeah, so I guess now I'm reading it, it's these are 110 volts is RMS value. So these have to be RMS value. And this is average power. So what is the RMS current in the primary coil? So yeah, V in I in equal to V out I out. I in is V out. So 12 volts divided by 110 volts, and these are all 4.17 amps. So 0.45 amps. Again, current went up from this to that, and voltage went down from this to that. What is the ratio of the number of primary to secondary turns? So V2 by V1 equal to N2 by N1. V2 was 12 volts, that's 110 volts. So for every 1 turn in the secondary coil, there's 9.2 turns in the primary coil. So this is a step down transformer. What is the resistance of the train? The power out is V square over R. So R is 12 volts square. And it's a 50-watt train, yeah. What is the resistance seen by the 110-watt source? Power in is equal to power out. So here the impedance is 242 watts, and here the impedance was, what was the impedance, input impedance? Oh yeah. What was the output resistance? Okay, output resistance was that 2.88 ohms. Okay. All right, that finishes the problem.